I don't think is talked enough about in the conversation on climate change is the importance of biodiversity. I mean, I think when most people hear biodiversity being important, they inherently understand that or accept that yes, that's true. But what's really interesting is that we focus so much on carbon, and we're seeing a lot of organizations now trying to go carbon neutral or go net zero. But I don't think we're emphasizing the importance of biodiversity to the degree that it should be. And to really understand this, we need to kind of unpack the science a bit. So why biodiversity is so important goes back to the second law of thermodynamics, which you may have forgotten about from your grade 11 chemistry or physics class. The second law of thermodynamics is really about dissipating gradients. And life is this beautiful representation of a gradient dissipator. So if you think of the earth like a pot of water, and you put that pot of water on a stove, when you turn on the elements, it's creating the same experience as the sun hitting the earth. So the sun is creating this very high quality energy called exergy. And this energy is hitting the earth, and the earth has to do something in response to that gradient. Just like when you put a pot of water on a stove and you turn that stove off, you have this gradient that's created. You have a lot of high energy or high heat in one area and low heat in the other. So as that heat dissipates, that vessel, that pot of water, needs to deal with that gradient. And so what naturally happens in your pot of water is that you'll start to see these bubbles form. And then eventually these bubbles turn into these perfect kind of oval shapes, these convection cells. What that pot of water is doing is it's naturally self-organizing into the most perfect patterns to dissipate that gradient. This is the very same metaphor or experience that's happening on Earth. As the sun hits the Earth with this high quality energy, this Earth has to deal with that gradient. And nature is a perfect dissipating structure. So what happens is life will take that high quality energy and start to use it in different forms. So leaves will take that energy, turn it into sugars. Herbivores will eat those leaves and turn that energy, those sugars, into movement, into reproduction, into chemical experiences within the body. And what it's doing is it's taking that high quality energy and slowly dissipating it into its lowest form, which is heat. So when you leave life be, as long as the sun is shining, life will take that gradient and dissipate it. Nature's always constantly striving for equilibrium. It's striving for that place with zero gradient. This is why it's so interesting that humans seem to disrupt that equilibrium. We're very disruptive to this natural process that's occurring. And the disruption has an intense consequence, because as we disrupt this system, which is naturally dissipating the sun's energy, we're taking away that ability to create equilibrium. We're actually making more disruption than just our simple disruption causes. For example, when you cut down trees, or if you try to grow monoculture crops, what you're doing is you're taking away those pathways for that high quality energy to be used up in many different forms. So another principle is that if you leave nature alone, it will naturally strive for the highest diversity possible, because that diversity allows many pathways for that sun's energy to be used up. That's why biodiversity is so important, is because it's this natural system that is dissipating the energy from the sun. Now you think, well, what's so important about dissipating the energy of the sun? Well, if you think about life as this dissipative structure, if it's not here, that gradient has to be dissipated in other ways. And other great forms in nature are vortexes, or hurricanes, or tornadoes, or massive storm events. Those are all natural self-organizing structures, just like those convection cells in your pot of water. And those systems will do the same thing that life does, but just with much more chaos and uncertainty. A tornado is a great dissipative structure. A hurricane is a great dissipative structure. Storm events are great dissipative structures, but they leave us with much less control than a beautiful ecosystem. So as you're cutting, as you're farming, as you're developing, as we're growing, and as we're separating urban environments from natural environments, what we're really doing is disrupting the natural order for nature to dissipate the gradients of this planet to help give us general equilibrium. Nature is pushed away from that equilibrium, but constantly adapts and changes and makes small adaptations to become the most effective dissipative structure it can. So if we just let it be, it would be taking care of us even more than providing the air, dissipating storms, collecting carbon, providing nutrients in soils. All of these ecological services allow humans to survive. But what we don't talk enough about is how diverse natural ecosystems really help us to thrive, because they give us stability. They give us that sense of equilibrium because it's a massive dissipative structure. And yeah, the more we cut, the more chaos we're creating.